With that, I think I'll get us started. As people come in, sort of the logistics and marching orders for everybody. If you're not speaking, please mute yourself. We can also mute you from the command post. But if you have a question that you want to ask while a presentation is happening or after one is finished, raise your hands, and I'll unmute you and recognize you to go ahead and ask your questions. And we're going to have 3 presentations today. An initial opening with Dave Bruno from Connecticut Innovations, then introducing our 3 speakers. Each one will do a medium-sized, medium presentation, and then we will have questions about that presentation and move on to the next one, all taking place within about the next hour or so. And so with that, I will turn it over to you, Dave. And if everybody else could mute, other than you, and we will begin.
Thank you. This has been very well organized, so thank you. Also to Lena, who helped us originally set this up and vet the concept. I met with Kathy over in stores, and she kind of briefed me on how your group worked, and we kind of pre-looked at the companies we should bring. So we've curated a selection of them. So I'm Dave. I'm from Connecticut Innovations. It's the state's venture capital investing arm into new technologies. Our primary mission is to bring companies to the state that have new technology that we can extend, create jobs here, and scale up companies. So we've been very successful in the last, say, 20 years. We produce a lot more capital flow than we use in terms of companies we've exited to IPOs, et cetera. So our primary focus has traditionally been in biotech and healthcare, but we've really gotten into climate. So we're launching a new $100 million climate fund this year. And we have existing portfolio companies, 3 of whom are here, like I said, curation. So you're going to see 3 today. So Al, if you don't mind going first with Budderfly, and then we'll just go alphabetically. So Perry will look at Cadenza, which is in battery backup power. And then Dan has cutting edge technology in HVAC and boiler. And between the 3, we felt like it was a good thing for you to see if there's a need to run pilots or do testings to validate tech. We'll actually pay to stand those up and help put in place the safety guidelines and rails for you to try out these new technologies. So just so you know, the governor put this into his legislation last year in simplification so that we can move things through a process and validate them without having to pre-procure them and do RFPs. So it's actually a fast track to procurement in some cases where it's useful. So with that, Al, if you don't mind, I'll hand over. We're going to try to do about 10-minute presentations with Q&A directly after each.
Great. Hey, Dave, if while I begin, if you could bring the deck up, if that's not hard for you to do, I'm on my iPad right now. If not, I will be brief and articulate enough. I think everyone will understand.
Go ahead and start and I'll pull it up.
First of all, thank you, everyone, for joining. Very quick on the company, and then I'll get into the model. I'm Connecticut born. I went to college here at Trinity. I have built 3 companies in the state. This is my 3rd. This one's growing, 5x faster than all my others. I don't know if it's my age and I'm smarter or just getting lucky or whatever it may be. But we today are just surpassing 70 million in revenue, almost a double of what we were about 10, 12 months ago. And I tell you that less for a pat on the back and more for a testament of both the macro environment that we're in with a big desire to drop carbon and impact the environment. But Budderfly has aligned that outcome with also saving money. Both are important. I will tell you that philosophically, when I created the model, and I'm about ready to tell you about it, I aligned capitalism perfectly with saving the world. And because I felt like you needed selfish dollars to go after unselfish outcomes, if everybody understands that. We have built a model that no one else has built. I'm right or wrong, I've been through too many private equity firms to answer that question, and everyone has confirmed that to be the case. And for a while, I got nervous that we might be doing something so weird, no one else would do it. But I actually think it's just so hard, nobody else has done it, and we've pulled it off. We just announced the $500 million funding 60 days ago with a large private equity firm who's in the infrastructure space. We have plenty of capital to do all the things that we want to do. So let me get into the model. I'll be brief. You can poke around and ask some questions. So Couple things about the energy space that have bugged me, and the other people on the call probably face these challenges, is you end up having to spend money, usually your own money. Sometimes it's offset by the government, sometimes it's not, with incentives. But usually there's a lot of checks that have to get written to do a lot of different things to be what I would call creating the optimal outcome of the lowest carbon footprint you could create. And in some cases, zero carbon footprint. That would involve you investing in lots of different things. Environment like HVAC and heating, you'll hear some about that today. Renewables, which could be solar or fuel cells, better insulation, refrigeration, controls, and the list goes on. And it's very, it's very difficult to fight through all the complexity to get through it. And therefore, people normally take way too long to get it done. And it's hard to find the money to get it done. And therefore, everybody cuts it short. They shortcut, and they usually don't get a lot done. That's kind of where we are today. So at Budderfly, what we did is something different. We decided to take over the problem, the entire problem, not just one part of the problem. And we take over the account with the utility. So Budderfly becomes customer with the utility. We end up billing the actual utility services, but we give complete visibility to the actual utility data. Then we go off and we spend our own capital on upgrading all the things that need to be upgraded. And we do that on pretty much our own nickel. We have plenty of capital to get that done, which is good. And we put in all the things that you would otherwise try to do on your own, and we put them in efficiently with a goal to drive that consumption down to the lowest amount that is possible with the best equipment that, frankly, peoplekind makes today in the world. And we take care of all the labor. We take care of all the acquisition of all that. We buy everything at cost, so there's no margins. We don't really sell anything. And because we control the bill, we pass the savings on to the customer through the billing, no questions asked. So the customer gets to walk away with a budget reduction. We then go buy all these things and we drive that consumption down much further, enough that ultimately pays for all that. We bear the risk of that. And then hopefully we do even better than that, and enough to make some money so that we can continue to do these great things for the world.
Tell me if I'm on the right slide.
Yeah, that's good. People can read it. Hopefully you'll walk away with even half of what I say. And obviously this is an introductory meeting and maybe one that'll lead to others. And the model is simple for the customer. It's a little bit weird. I think the biggest objection we get from people is, sounds too good to be true, Al, because we don't expect the customer to write a check for anything. It's really that simple. Really just turn over the utility, gain savings immediately, and then we go spend money on, frankly, all the best things you would ever buy, and we go do all the work. And we manage the economics in a fully transparent model. There's not much we don't do in this, and our view of it is, I think today, we're doing, I'd say, 200 installations a month right now, 200 different facilities throughout the country. Pretty high volume. That number's going up. We outsource about 90% of the labor that gets done with electricians, HVAC specialists, refrigeration, et cetera. We're highly certified. We built a lot of software to do all this incredibly well. We're based there in Connecticut. We're probably 140 people now, and we're targeting to hire close to 100 people in the next 12 months. We'll try to hire 70 to 80% of that in Connecticut would be the goal. We're based in Shelton, Connecticut. So that's a very quick view. The carbon footprint that we anticipate driving is about 30% without renewables. If we add renewables, we try to double and triple that, go to a zero carbon footprint model. Our big believer is, do not pay for a renewable for an ounce of energy that you don't need to use. So efficiency, I believe, is number one. It's the first thing we ought to address. You know, why put in or use an old HVAC unit when you can replace it with a high efficient one and save 60% on that use? Same thing with LED lighting as an example, or, you know, better insulation to save energy before I put a renewable in and waste money on building solar out for a kilowatt hour that I just don't need to use. So we're scientists in applying this model. And obviously we're going great guns in the market right now. I think we were the 10th fastest growing company in the country last year as a result of this, and are obviously excited to chat with you more about this. So that's my quick nickel tour on the model. And obviously I open up for questions.
All right, thanks, Al. This is Dean. If you have a question, raise your hand, and then you can unmute yourself. Yeah, okay, Chuck first. Chuck Liddy.
Yeah, so what's the scope of this in terms of the customers that you serve? Is it multifamily? Is it municipalities? Is it single family?
So, yep, I am an open book. It has not been to date a lot of that. We started out, we landed another Connecticut company called Subway. You guys know who they are. And I think we're up to 2,500 subways, and we're banging out, 150 to 300 a quarter still. That's gotten us into that marketplace. I say that openly because we've formed a niche in that space. I know that's not overly relevant. That said, we've done a whole lot of office buildings. We like not to do huge office buildings with heavy engineering things. We like to do things that are repeatable, that you would do over and over again. Municipalities are a pretty good fit for us. We haven't done any yet. Part of it is we are so damn busy growing right now, and to be candid with all of you, our hair is a little bit on fire. And that's not something that I would normally say, but when you're growing, we're probably growing near 100% a year right now. But obviously the team wanted me to present. We're Connecticut based. I believe the model works really well in your marketplace. We would be open to certainly entertain exploring further with you if you folks are up for it, but we certainly don't have to.
So, but let's move over to Paul Sell now with a question. You can unmute, Paul, and you're up.
Yeah, thanks. So I'm an architect, and we do a lot of both new construction and renovation. So my question for you is, are you working with existing companies that are looking to replace product and you're putting a new product, or are you working with the architects and design teams, mechanical, electrical engineers, on actually specifying new product for new construction and getting your systems, in from day one?
Most of what we've done to date are retro. And again, I bring that up to you because there's so much to do and we're doing a lot of it. We haven't done as much new build. We do work with local engineers and architects when certainly necessary, but we move at great speed, but we'll probably be bigger on retro. We put in brand new and we upgrade. HVAC as an example, we'll often upgrade units. We're probably bigger in the RTU space than we are in the huge chiller, even though we've done a bunch here in Connecticut on the larger side. But we'll also, if we think an HVAC unit's kind of too old to upgrade, we'll just buy a brand new one and put it in.
Okay, thank you.
Yeah, I had a couple of questions that I jotted down, Al. One, on the operations side, I mean, it sounds to me like this is a typology-focused ESCO with a special connection to the utility where you're paying the bills rather than just taking some percentage from the companies, which is very clever, I think. And if you're doing that on the operations side, so you're maintaining the savings, right? I thought I heard you say you're operating these systems that you put in. How does that, is that like a large scale contract with a subway, or how do you actually do that building by building?
So you're right. I'm not a big lover of the word ESCO. That's just me. I can be fairly blunt, but I apologize when I say that. I find those agreements to be complicated. They're usually 90 pages. Our agreement's 2 pages. Really simple. We do it on a 10-year deal. Really simple. It's 10-year, and we need 10 years to amortize everything. It's not unlike a solar PPA, who has to spread the capital cost over a period of time. But what was different is we do all the things that we can do, and we drive the consumption down enough to cover that cost. Customer doesn't worry about that. It's more than, I don't even like the word guarantee because it's better than that. It's contractual. And you are right. We take the bill over. We basically like to create a baseline of history. And if we can baseline a facility, we lock it in and we apply a discount to consumption, and then our software will take all the current rates and simply re-render the utility bill in the same way they do it with a lower consumption number. So that's how, we've been called clever before. I've been called other things too, but clever was the
The
good.
clever ESCO.
So, Dean, if you don't mind, I'm going to move us to Cadenza. And Al, thank you so much for joining, because we wanted you to get a sense when we looked at the projects that are going on. We think that there's probably some companies here now that are ready to be specable, and they do lead to jobs in the state, taxes in the state, and in most cases, they're the national competitor to beat at this point. And so we wanted to make you aware of them and see them. If you have additional questions, send those in so that we can look at them and engage in single conversations.
And we may have some time at the end, Dave. They're committed to staying till around 1. So if you guys
Okay.
are,
Oh, so we do have time.
Yeah.
One more question for Al, or?
Is there anybody up? I'm not seeing anybody. Nope. Why don't we move on, and then we can, I have another for Al, but let's move on and then we'll come back.
Okay, I'll be here.
Perry, do you have your own slides to pull up?
Yep, I have my own slides. I'll bring that up now.
Okay.
There you go. You guys got that all right? Okay, so I'm Perry Wyatt. I'm the Vice President of Products for Cadenza Innovation. We're an energy storage company located here in Connecticut, very much focused on safety and deployment across a number of different solutions. Cadenza was formed by a bunch of industry experts in lithium ion. So we have a very rich technical background with lithium ion. It really sets us apart from a lot of our competitors who are entering the market today. Part of our leadership team was some of the first to develop gigawatt-hour factories around PC and consumer electronic batteries. I've had a long history in automotive myself. So we know what we're doing. We know how to bring energy storage to the market. And our mission in coming together here is we see a real lack of attention to safety in energy storage. And we don't think it's been pervasive yet in commercial installations or grid tie energy storage, but we see that coming and we intend to fix it. So that's our mission. So let me tell you a little bit about our products. I'm going to focus on this today. Our roadmap extends out into a very large energy storage, utility scale energy storage. But in the near term, we're very much focused on low voltage installations, which really bring us to the conversation today around multifamily. The products that we have, we call them the VPP series. It's a virtual power plant series. I'll get into a little bit about what that means through the presentation. We have everything from a 20 kilowatt hour indoor, that's about the size, of a small refrigerator, to the 40 kilowatt scalable solution, which can be rack mounted, a little bit more of a commercial installation, which could go in utility closets or other indoor installations. And then we can also scale all the way up to large pad mounted installations for outdoor areas. These are all tied together with a Cadenza cloud. So the way that we do this is all these batteries can basically work in harmony. They communicate through the cloud and they can be remotely controlled by Cadenza, which is really important when we get to unlocking a lot of these grid tie incentives. As a little bit of background where we are in our evolution as a company, we're really centered around a core technology, which is based on safety, high performance, and low cost. Safety being at the key for this. It's important to us as we penetrate the market. Our niche is really about dense urban environments where we can be located close to population centers. So we've proven this with a very large installation, which we worked on in conjunction with the New York Power Authority and Hitachi ABB. This is a 250 kilowatt hour system, which sits, you can see, about 10 feet away from the wall at the NYPA headquarters in downtown White Plains. That we've gone through a lot of permitting to prove the safety and the ability of our battery to be located so closely. And actually, we think that this sets the groundwork for us to fit very well into multifamily as a next step. So the safety is there and it's proven, the technology is proven, and now we're penetrating new markets. So we have a global approach. from a local perspective, we're really about decreasing the cost of energy storage. This comes from this approach to the overall system and how you do the installation. But we also have a global approach. Our mission, as I mentioned, is really about safety and accessibility. And we think that that's at the core. Energy storage is going to be pervasive across the entire renewable spectrum. It's necessary to control all these varying inputs and loads, and safety is going to be at the core for that. So, our mission is to have power of the responsibility and to diversify the clean energy space for everyone. So as we're looking at multifamily, some of the things that this unit can provide, obviously we have peak shaving benefits. This can be very beneficial depending on the utility rates and time of use rates. We're seeing increasing demand charges, across all the utilities today, where we have very high peak and even super peak rates in certain districts. And we can use the batteries to shave those rates off completely. What that also does is it decreases the load on the local substations, decreases the amount of time that peaker plants need to run. So that definitely directly reduces carbon emissions. We can also work in conjunction with demand response programs like we have here in Connecticut, where we work with Eversource, for instance, to schedule the battery to discharge during peak times during the day. There's obviously a financial incentive for the owner for that, to all these type of grid tie benefits. And anytime you have batteries, there's always the opportunity to increase resiliency through backup power and being able to use it for that type of function. So originally, that's why people looked at adding batteries to their homes, was for the backup function. But when you go to lithium ion, you increase that by having cyclability, so then you can really unlock these other benefits as well. You asked for a little bit from an architecture perspective on what these units look like. So there's a couple of different variants, and we're coming kind of newly exploring the field of multifamily right now. I think this is a perfect time to have this call and talk to some experts. But we have a couple of different ways that we can do this. We can do it purely indoor, where this could be something visible to the tenant. Like I said, it's a small indoor box with a 24 by 24 inch footprint, about 35 inches high. There's also an inverter which would be attached to this, potentially wall mounted. Or we can do these in racks. The racks are highly scalable. So we could do anything in these racks you see on the lower side here, from 20 kilowatt hours, which would be a pretty large unit for a single family, maybe 15 to 20 kilowatt hour, and then scale that all the way up to 80 kilowatt hours, which would be 2 of these racks to maybe service 4 different apartments off of the 1 rack system. So there's a number of different ways that we could install these in the sites and basically link in multi apartments to them all. Even if they're dispersed across a site, the batteries still all operate in concert. So if you were sub-metering, then you had the meter that the landowner or the landlord owned, we could regulate all the batteries to work together, and you could basically function as a virtual power plant across the entire site and reduce overall peak load for the building. So we've gone through some of the benefits. Obviously, backup capability, scalability is a big thing. We're always going to have a view towards installation costs. That's going to be really important, and that's why we're looking at some of these rack-mounted systems to reduce the installation cost and maintenance costs, which are already very low when you go to lithium ion. We have this peak shaving capability. And like I said, everything is controlled through the Cadenza cloud. So all the peak shaving control, all of the demand response, managing it with Eversource, managing it with the utility, the DERMS provider, that's all done and handled through our cloud services as well. Number of different options, I'd say. If you look at where we are right now, we're really soliciting feedback as far as where these batteries could be mounted within the buildings, and whether or not it could be a showcase, with a glass door. It could be rack mounted, where we put it behind a door in the utility closet, or it could even be outdoor, which is the type of installation that we do today with small commercial installations. So I've gone through a little bit. I won't want to be careful with everybody's time here, but basically all of these functions that I talked about, they all result in some kind of an economic payback for the project owner or the site owner. We have a number of different models that we entertain with this. Today, we're deploying these across different commercial and industrial sites, particularly paired with solar to date. But now with the new IRA, the Inflation Reduction Act, that's providing 30 to 50% federal tax credit for the battery alone. So this is a game changer for us. It actually decouples the need from pairing batteries with solar. And now we can have a very strong business case on battery alone. That's another big differentiator for Cadenza. We are not a solar company who's added on batteries. We are a battery company first, and we don't require all the inverters and the infrastructure and the solar tie that's really fundamental to the technologies of a lot of our competitors that are solar companies. So what we're looking for today, as we're entering this new space, we think multifamily is super exciting for us. We think it serves a great need in Connecticut, and particularly even going into lower income. That's something that we've been talking a lot about, but this is really the opportunity now with the new IRA to really penetrate that market. We're looking for partnerships in this. We'd like to solicit feedback from multifamily building owners. We want to understand the pains, understand where they're looking for the financial gain, the profitability. There's a number of different models that we can deploy. And we'd also like to solicit feedback as far as our product evolution and how we can better shape this product to fit into your site. So we definitely love to work with you and appreciate the time with you today.
Great, thank you, Perry. I'm looking now for questions from the group. Anybody, because we're going to take a few minutes now to talk about Perry's the Cadenza products, and they're coming to market. Does anybody have a question to ask? Raise your hand and I will. I thought a hand, oh, there we go. Seema, yeah, there you go. Yeah, go ahead.
Thank you, Perry. This was really great. I have two questions for you. One, what kind of backup are we looking in terms of number of days? I work in the affordable multifamily space. So what kind of backup? And second is how, what would be the integration with the solar piece? That's really what we're trying to encourage.
I'd be interested in understanding your requirements for backup. Batteries in general will provide a number of hours of backup rather than days of backup. So it's kind of dependent on the load for each residence. But what we could see, and especially when we work in this type of, if we're sub-metering and then we have a larger battery basically functioning as a larger battery sitting behind that, we can even out the loads across the whole building and optimize a longer backup time. And we're probably talking, anywhere there, it could be, if we're sizing the battery very small, down to 2 hours, but it could be all the way up to 8 hours, so 2 to 8 hours. And then your question on integration with solar, that's really our roots. I think that's kind of the roots in energy storage in general in this type of grid tie incentive. So we tie directly in with the solar. We can monitor the solar. We can adapt the battery so that it's only charging during solar times if that's necessary for the locality. We also find in areas where there's peak or super peak, we want to charge in the middle of the night, obviously when the grid power is inexpensive. So that's all completely tunable.
I just have one follow-up question. Do you require back of meter solar installation, or would it work front of meter or back of meter installation? That's the piece that we are trying to solve. We are working on another policy.
Understood. Okay, so front of meter would be, it's just a different installation. It's probably more along the lines of the large type of system that we have running at NIPA. But that product line is much more slated for large solar, industrial solar installation support. So I'd love to talk to you about that. That's a different battery product, but we can certainly support that as well.
Thank you so much.
Mm-hmm.
Okay, Steve Hall. Hopefully we can hear you now.
Can you hear me?
Yeah, you're good. You're good.
Oh, good. Excellent. What will you do? I mean, in New York, local law 97, I understand, is driving all buildings to sub-meter. So I may be looking and working with a developer here in Connecticut where we may be sub-metering from the get-go to multifamily and multi-office commercial, how would you handle that as backup?
We're in a sub-metering situation that actually is ideal for energy storage because we go between the sub-meter and the main meter. And that allows us to deploy, we're basically behind the meter for the building, right? So we could deploy all these batteries as one very large installation for the whole building, or we can deploy them based on each individual sub-meter. You know, we're monitoring that as well, so that each residence or property could have its own, you know, backup availability, its own use case. You know, we could kind of optimize the bill for a unit, or we could optimize it for the building.
Great, thank you.
Other questions for Paul? I have one, Paul, that might be kind of, I'm trying to understand it. The battery systems that would be the small unit level, like we were talking about, maybe pictured here, or at the larger building level scale, are they solely for backup, or are they actually, could you use them for peak shaving, for cost savings? You could interact back and forth with them, charge them, decharge them over the course of the day or a week or a period of time, or are they really there just to get charged and be there in case backup is needed?
That's a great clarification. These are absolutely for more of the incentive, for more of the total reduction type of use case. So the peak shaving is one of the best cases for putting batteries in place. If a building is experiencing really high demand charge rates or peak charge rates, that's ideal to look at batteries because the battery can probably smooth that out. We find, for instance, in Brooklyn, from a lot of residents, we can just shave super peak completely. You know, and super peak could be 64 cents a kilowatt hour, you know, versus 7 cents in the middle of the night. So there's huge arbitrage opportunities for just a residential owner for that. So primarily our business case is based on either peak shaving, demand response, you know, or any type of benefit such as those grid type benefits. And then backup is honestly secondary. You know, that's what batteries used to be used for. That's when we're displacing lead acid. Lead acid can't do this because you really can't cycle it. But when you go to lithium ion, you get these benefits.
And that's why the 8 to 20 hours you quoted is, you know, sort of a max out there for the backup side, which they haven't. A quick follow on to that: are you coming to market as a vendor of product or a service provider, or both?
Both. There's a SaaS side to it, which is probably the longer term side of the business, but it's set up today. And then near term, we're very focused on the hardware deployment as well.
Cool. Okay. Chuck Liddy, you have a question? And then Neil.
I have a couple questions, but one is to just build on what Dean was asking. What does that do if you're using it in a demand response situation? What does that do to the battery life over the longer term?
And so we see, you know, 60, 65 discharges per summer on a demand response program. And those will be full depth of discharge cycles. Our term for the battery in that type of condition is probably 15 years of functionality. You know, we do 10-year warranties on top of it. So it's really not that heavy of a load for a lithium ion type of battery.
Okay.
And Neil Donnelly, did you have
Sorry,
one?
I wanted to ask another question. The
sorry.
main question I had.
Yeah, sir.
You've mentioned safety several times. How do you differentiate yourself in that space from your competitors?
That's simple. Our batteries don't have thermal propagation and they don't explode. So
could you get a little more color around that?
Yeah, I don't know. That's really what it is. So you see a lot in the news about batteries having these issues, especially in automotive. I think you're going to see more of that happening in utility. Unfortunately, you do. If you look at South Korea, for instance, where they have a number of installations, you know, they've had over 30 events in the last 5 years, major environmental disasters. You know, and that's what we don't want to make that, you know, a big part of the conversation. It's kind of a tough thing to talk about, but it's absolutely critical that we come in and we solve these issues.
Terrific. Okay, Dave, maybe we have one more time. Neil has a question, then we'll move on to the third speaker. Okay, Neil?
Thank you. I was curious on the peak shaving, if that is actually like tied into the current building demand or time-based, or how that's working.
We're seeing time-based utility rates right now, so that's actually fairly easy. When you know the periods of time when we want to make sure that the building isn't drawing any electricity off the grid and utilizing the batteries during that period. But we do have the ability to monitor. We will have the ability to monitor the local meter and have kind of just in time, reactionary peak shaving as well.
Terrific. Okay. Well, thanks, Perry. And Dave, yeah, we'll go to number 3.
All right.
Thank you. Number 3. Thanks.
Number 3 is Dan Nadav. He has Enviropower to show you. And we talked about this in, we actually pre-briefed this with Kathy Dorgan, and I think it'll be very interesting for you.
Thank you so much. Thanks for having us. My name is Dan. A little bit of a background, hard eye, renewable, clean tech person, 20 years in the career, pretty much all what I do. Multiple distributed generation technologies, including geothermal, waste heat recovery, many years in the wind industry, in the last 7 or so years in what's called micro combined heat and power. I like to resonate what Al mentioned about his company. I believe, Al, you said you bring a model that will save the world, which I definitely agree with you. But that makes money. And I'll rephrase it on our side. We bring equipment that will help to save the world and will make money. So what we do, I can tell you pretty much in one sentence. We provide boilers that generate electricity. It's that simple. We're empowering the heating infrastructure. Now let's talk about why and how. So we are focusing on one of the biggest and most interesting challenges in decarbonization, and this is decarbonization of existing buildings. As you know that, because I think that you're doing it day in, day out, decarbonizing existing buildings, those that are old and that were built in the 90s, 80s, 70s, 60s, and some many times way before that, when no one thought about energy efficiency, is really, really tough. You have potentially technologies, but some of them are immature, some of which are requiring a whole set of new workforce that basically does not really exist. And, it's economically challenging. We saw as a team here concerned about decarbonizing and decided to tackle that in buildings, a great opportunity in heating infrastructure. They exist in every building. And we decided to tackle that through the concept of micro combined heat and power, which I'm sure most of you understand. It's the idea of combining in one system the capacity to generate both heat and electricity. And when you do it properly, it's very, very efficient in lower carbon footprint. It saves a lot of money. And yet you don't find it in that many buildings. And the reason is that today, micro CHP, micro combined heat and power, is built around engines. People do not buy engines. You know it yourself. People buy heating systems. So the way I like to joke with our investors, when your boiler fails, you will replace it the same day, because otherwise no charge the next morning, or you just freeze at your home. So it's a non-discretionary product, the heating itself, not so much the engines that currently are designed for micro CHP. So we decided to take a very different approach, since people are in need for heating systems and they replace them as soon as they fail. Why not to design a micro combined heat and power around a heating system? So around 10 years ago, we took heating systems, boilers, and we almost literally cut them by half. And then we asked the research question, how we can integrate into a boiler geometry a generator at 2 conditions. One, without increasing the cost, and second, without interrupting its functionality, so it really stays a boiler. So when your customers are looking to replace a boiler or install a boiler in a new building, they can either buy a regular boiler that just provides heat, or they can buy a micro combined heat and power that is a drop-in replacement to regular boiler that provides both heat and power. And today we bring to market the first product out of that concept, called the SmartWatt boiler. It's in our opinion the perfect match for multifamily apartment buildings that are directly metered. basically where for each apartment has its own direct meter, but a central location for the heat. And the smarter boiler does exactly that. It's basically a drop-in replacement for regular heating system that provide electricity as well as backup power. And the way we do that, and allow me, because I know that we are talking to a group of people that are very knowledgeable, is try, I'm not sure I'll be successful, but this idea came to mind while listening to others, is to actually use a whiteboard to show you how it works. And I don't know if I can do that. Looks like I can. If you see the whiteboard, I'll start drafting something here.
Yep,
It's
looks
embarrassingly
cool.
simple, but we like things that are simple. Do you see my whiteboard?
Yes, we do.
Yeah, we
Thank
can see it. Yep.
Okay, very good. So in 60 seconds, I'll explain to you how it works. And I said it's embarrassingly simple. So, and sorry for my handwriting here. So I'm actually starting putting a description of a boiler. You know, the boiler, the fuel train inside, and basically the burner below, okay? I just put a boiler like any other boiler ever invented and basically ever produced. Where we come unique with our patents is the following. We put next to the heat exchanger, the burner, another heat exchanger. It's just another simple heat exchanger. Sorry, I'll put it here. And in this heat exchanger right now, you have a little bit of a water. When you turn on the boiler, the water will turn into steam, and that steam will actually go and move into, try it again, here, and expand into a turbine. The turbine is connected to a generator, and that's how we generate electricity. It's a closed loop power cycle. So on the other side, you have saturated steam, and we need to bring it back to water. So we actually put another heat exchanger at the bottom of the boiler where steam goes. And the way we actually bring the saturated steam back to liquid is by taking the return water, streaming back to the boiler from the home at the coldest temperature. And before they go back to the burner, they meet they meet the saturated steam and suck all the latent heat from the saturated steam, bring it back to liquid water, and then we pump it back and close a cycle. And the water from the heating loop goes back like any other boiler and back to the home. Basically, we integrated the most common, oldest power plant in the world into a boiler. We integrated a closed loop steam power cycle into a boiler. And the end result of that, and now let me try to go back to the presentation. Here we are. And tell me if I'm sharing back the presentation.
Yeah, we can see it.
Okay, is this? It's a smart boiler. It's a boiler with a power plant inside. The end result from the research that we performed in the last 10 years is a boiler with a power plant inside that has cost very similar to regular boilers, the same boilers that you spec day in, day out for your projects. It has almost identical installation process to regular boiler. The only exception that you do need to do something with the electricity. So you bring basically an inverter, the same exact inverter you use in any PV project. And it has identical maintenance cycle and cost to a regular boiler. So really give our customers the choice when they need a boiler, and all of them eventually, inevitably will need one, to choose either they buy a regular boiler or pretty much the same price buy a boiler that can generate electricity and also provide them with backup power. Now, few words, that's the boiler from the inside. Just wanted to give you an idea. That's the boiler part, and on the left side, it's the integrated power plant, so to speak. The integrated steam turbine works perfectly, together with the heating side. The cost of the turbine is relatively low. At scale, we're talking about additional $1,000, which is nothing compared to what you pay to a boiler. So very small premium relative to boilers. A little bit of an economics. Basically, think about it. So the product we have right now in the market as a 6 kW turbine. It's designed to match perfectly the common area meter in all those direct meter multifamily apartment buildings, where the meter where it makes more sense to connect is the common area. Common areas between 4 to 8, so we came up with 6. And when you operate that in New York, in New Jersey, in Connecticut, with an environment of 20 cents per kilowatt hour, this product will save $1.2 every hour of operation. And since domestic hot water is the mother of baseload, you need it day in, day out, summer or winter. We're talking about thousands of hours of operation per year, and something that can come up to $10,000, on electric savings in some buildings. The product is also part of the Inflation Reduction Act as a waste heat recovery technology. It basically can capture up to 40% of the power cycle, estimated at $6,000 per product. It also carry the makers, the depreciation appreciated bonus, and also it's subject to net metering in some states, many of the relevant states here in the Northeast. One other advantage, major advantage, when we take our approach, is that you belong to the boiler industry. So it's true that we are relatively a young company, but we didn't see any reason, because we are a boiler, to try to produce it ourselves, when around us here in the Northeast, we have at least half a dozen boiler producers that are second, sometimes third generation in this business. So we aligned with one of the largest boiler producers in the country, Burnham Holdings, to produce our boiler. Burnham Holdings is the mother company of known brand names in the US, including Thermal Solutions, US Boiler, Bryan Steam, etc. Very well-established companies with multiple production facilities. Not only they produce the smart watt boiler, they also provide the warranty to the product and second level service. So from that end, still being a young company, we are tapped to almost endless production capacity as far as we concerned. Today, we can already tackle orders in the few hundreds of systems per year, and we'll increase from there to the thousands per year. I wanted to complete my short presentation here by giving you an idea about the savings and the cost. So we work with a few of the largest real estate companies in the world. One of them is Fairstead. You may have heard, a company that owns in New York around 200 apartment buildings and is specifically focusing on low, medium income, government supported buildings. This is a building in Harlem, 210, 226 in West 150th Street, side part of Harlem. And this building can take a smart watt boiler, the 6.0. We always, start with a fairly detailed analysis of the gas and electric bills. Here you see basically the saving analysis and the end result of that. And I'll be more than happy to share this entire deck of documents and analysis after the call with everyone who is interested. Basically, the cost of such a project, obviously in New York, a bit more costly, is around $43,000. The savings is around $14,000 per year. So very, very quick payback on the entire project installation. Obviously, if this project is about replacing another boiler, then the return is not on the investment, the return is on the premium. It makes it even shorter, sometimes counted in few months. Today, we passed certification, we passed UL certification. We start serial production with Burnham this year. We have 2 pre-serially produced systems installed already here in Connecticut. One is with Wesleyan University in the Butterfield dormitory building, and the other one with the multifamily apartment building in Simsbury here in Connecticut, where it would also feed and support EV charging stations, producing the electricity locally. And with that, I think I'm done. Thank you.
Told you it'd be interesting. Stephen, you have a question.
I'm sorry?
Yes, I have a question on this.
Please.
Yep.
You're powering your boilers with natural gas, correct?
Natural gas or propane. We will start testing next year with ATCO, the largest utility in Canada, for hydrogen.
Good, that's good. But how in New York City, local law 97 is going to phase out gas-fired boilers, as I understand it, in New York City.
So those are futuristic plans. I don't hold the crystal balls. My simple answer to something that claimed to happen in 15 years, that in 15 years we may be well using hydrogen. But if you check for, I'm more interested about the present or the near future. In the present and the near future, if you save a kilowatt hour electric as opposed to kilowatt hour of gas, you will reduce more carbon footprint with the saving kilowatt hour of electricity at a factor of 1.5.
Okay,
Those
so
are the numbers.
you're saying your net
If you look at the
emissions,
97.
you're
Say
saying
again?
net emissions are actually lower using your boiler.
Today, absolutely yes. Our emissions associated with the kilowatt hour electricity that we generate are around 0.39 pounds per kilowatt hour. And in New York, it's still in the 0.5 pounds per kilowatt hour.
Okay, thanks.
Sure. And of course, I'm more than happy to support this discussion later on with the right documents and calculations.
Thank you.
Okay.
Thank you.
Not seeing any questions. I had a couple, Dan. First of all, when you're doing a boiler replacement, like you showed that one in Harlem, right? Do you build your boiler to that capacity? Or do you have a series of modular boilers that you string together to meet that capacity? Because it'll vary from building to building, size to size. How do you handle the variation in the load on the boiler you're replacing?
So our boiler is not small. Our boiler is 300,000 BTUs. Together with a tank of around 200 gallons to 500 gallons, we can actually manage most of the loads for buildings up to 50 apartments. And when I'm talking about loads, I'm talking about domestic hot water. It's true that this is a boiler. This can provide hot water for domestic hot water and space heating. But the jewel on the crown, really what we had in mind when we designed that are those tens of thousands of multifamily apartment buildings that have 30 to 50 to 60 apartments that needs domestic hot water for showers, etc., day in, day out. That's what we really aim to provide, because that's how you maximize the runtime. Summer or winter, we will run.
Okay, and that's a lower temperature application. So when you go from the steam that you've now dissipated a bit through the turbine and it comes back in, it's heating water, it's contributing to the heating of water for domestic hot water, not for heating.
Ideally, the ideal condition for this system to maximize its savings and the reduction in carbon footprint will be in domestic hot water applications. But it doesn't mean that if you have, for example, a smaller multifamily apartment building. So let's compare just two examples. 60 apartment buildings will have so much demand for domestic hot water that this system will never shut down. We're talking about 24 hours operation with a buffer tank. But let's talk about the building with 10 apartments. The domestic hot water is obviously lower, and therefore it makes sense to tap also into the space heating loop, and we can do that, and we are doing it.
Terrific. Okay, Chuck Liddy had a question. Chuck, you want to come on? You're muted for right now, Chuck, but.
Thank you. I had really a couple of questions. One is, those payback periods, are they based on with or without the tax incentives and other rebates that are available, to help?
They are without, specifically because we actually put that together before IRA. And with IRA, it will be lower. By the way, we're working very closely with Novogradac, the accounting company that specializes in this field, and we will come with very interesting models to allow our customers to capture the tax credit.
And then just extending that to the case where you might want to apply this to space heating, right, rather than just domestic hot water, which is, it might be more the mainstream approach in office buildings. What do the payback periods look like?
The payback period in those situations will be somewhat lower, probably in the 3 to 4 years, or maybe 5, depends also the electric environment. I do want to say that one of our main interests is to supply our smart water boiler to low, medium income apartment buildings. And as we start serial production, we have a few marketing systems that we will provide either for free or a deep discount. So first come, first serve, if there's any interest on your end.
You heard it here first. Okay. Chuck, did you have another question? Or are you good?
Well, there's about 1 million, but not for this call.
Okay.
Thank you.
I had one more for you, Dan, and then maybe we'll turn it back over to Dave. The power that's generated, the electricity that's generated, what happens to it? I mean, do you run it back into the grid? Is it how does it utilized and monetized?
Yeah, so also on that, and we want to think that we were smart. Channeling back to the grid, it's really tricky because sometimes it incentivizes, sometimes it's disincentivized, depends on the state and the flavor of the day. But for sure is that the landlords, when they can produce electricity for free, wants to use it at the building because that's where you maximize the savings against what the utility will charge you. So this specific product, and I believe that we'll take the same approach with other projects that we design, is really designed to feed behind the meter, that most of the time, if not all the time, the electrons will be actually consumed by the building itself.
And that you have the connections for that. Your company makes the connections from the turbine into the system.
Yeah,
or...
the connection is super simple. We are using inverters, ABB and other inverters that the exact same inverters that you will be using in any solar PV, rooftop PV project.
Gotcha. Okay. Let's see. I don't see any other questions here. So
Charles Emerson, who unmuted, I'm not sure.
Yeah, I'm sorry.
Charles Emerson had unmuted. I don't know if he has a question.
Yeah, Charles.
Dean, Paul, that was my question as well. So thank you.
Okay. We're here to serve.
Thanks so much for the opportunity to present.
Neil Donnelly had a question quickly. Go ahead, Neil.
Just on when you were talking about using these as a backup solution, what kind of electric output are we talking about?
So are you talking about backup power solution?
Correct.
Yeah, so the essence is the turbine itself. In this specific product, we are talking about 6 kW, but depends on the battery size and the choice of the battery technology. It can be obviously much more if we store it in, for example, another 10 kWh battery. So then you have a continuous 6 kW plus your 10 kWh battery. For example, a Tesla Powerwall attached.
Okay, so there's no more questions right now, but Dave does point out it seems like there's some interest in continuing some conversations with you guys. We certainly have a few minutes now that we can do that if you guys are still available. But in the future, maybe we should send out. We could send out to certainly everybody who attended today your contact information if you want us to. I'm assuming you do. And this is going to be, it's recorded, so it's going to be available through the Connecticut Green Bank and the P2P network. But, this is a pretty intriguing set of presentations from my perspective, and an intriguing set of questions it starts to raise. I think there's probably wants to be more conversation. So why don't we, Dave, plan to do this? We'll send out the contact information for all of you guys to everybody who attended, and then maybe we can have a sidebar about how we make this more available to the rest of the P2P, which is a much larger network. Maybe talk that through with Kathy and Rudy and some others, if that's good for you guys. So this is very cool.
You summarized it, Dean. I don't have any other words for you. Just we're trying to create awareness that these solutions are here, that they're from Connecticut, actually, and we're a little bit proud of that. So we've been early stage investors in some things that matters. And if you can make use of it, we'd be super proud to see that get into the state. So we have one of the representatives in the governor's Clean Energy Council. He's actually the leader of our climate fund. And we're doing a Venture Clash event on October 27th, where the Gov and many of the commissioners who come. I unfortunately didn't address the commissioner when she popped on here for a good half an hour. But there's a lot of interest at the senior level to kind of fix what we've historically had as a state, and we're still a leader in green energy. So trying to do our job. So thank you all for coming, and the questions were fantastic.
Yeah, and we still have some time if there's any final questions for Al, Perry, or Dan, or Dave. You know, this is your chance. Don't blow it. If you want to get some questions out to people. Yeah, Paul Selnow has one.
Yeah, so like several others, I probably have many that, because I've got several projects that I'm working on where I think this could fit in a number of different ways. You know, I've got a deep energy retrofit I'm working on. I've got passive house buildings I'm working on. You know, I've got something along with a very intensive geothermal system. So this brings a lot of questions to mind. So I'd really would be very happy to have everyone's contact information and just maybe reach out and, you know, see what can develop. Because I see some opportunities for many of these, if not all of these, three in several of my projects, frankly.
Yeah, cool. Well, that's what you guys wanted to hear, isn't it? So
Yeah,
we're glad you came.
yeah, maybe it was. I'm glad. Yeah, it was very, very interesting. I found it very, very interesting.
So did
Thank
I. Fantastic.
It's good. We had no idea before we spoke with Department of Housing how big we didn't know about the peer-to-peer group. So it's just a process of learning. We're talking with Pura and Green Bank and all the other agencies involved, but it was like, wow, we have places where there's architects working on speccing this and we're not getting the information to them. So
Yeah.
it's
And I'm
very
sure Kathy's talked to you about, you know,
Yeah,
Connecticut
sure.
AIA and others that are, you know, connected in too. So yeah, we're
There's
sort of
a-
networking. We're networked out to other networks. So you know, we're happy to help push this stuff forward.
Petra, if y'all know him, is coming by next Tuesday as well. And some of these same founders are going to present to him. So he runs real estate and construction for the state, meaning state buildings.
Yeah, cool.
For state employees. He has 7 million square feet of buildings. Plus he's doing all the tech high school builds. Maybe some of you are working on that. So trying to just join it all up.
Yeah, terrific.
I'm
Okay.
also a member of the CT Municipality Energy Network, and I think they would be interested in this as well.
Yeah, so maybe what we can do maybe Dave, you'll send us the contact info. Is that cool? And then we'll flash it back out to everybody here, but maybe encourage them to send it to their networks and reference this presentation, which will be archived on the Green Bank site, our section of the Green Bank site. So maybe we'll draft some kind of a, you know, Chuck, a letter that you could send to your group, and maybe others can think of theirs too, with the URL to get this. Vicki, it'll be posted up in about a day, 2 days, something like
Yeah,
that.
about a day or 2 days. It should be up by
Happy to
sometime
the YouTube-
Monday.
The private feed is good, but we're happy to do another demonstration because the questions are always different and interesting in different
Yeah.
ways. So
Okay,
Yeah.
we'll draft up something that'll work for that and send it out to tomorrow probably, or by Monday at the latest. So
sorry to speak for your
Okay.
time, guys, but Perry and Al and Dan, but I think it's valuable.
yeah, no, it was really great. So okay, last chance, everybody on the call. 3, 2, 1. Okay, we're done with the questions. Thanks, everybody. The P2P network. Just be informed that we are now beginning to build out the rest of the year and into 2023. We're going to have a meeting next week to discuss some potential ideas for other speakers and things to come in. And as we said in the beginning, we're hoping to start getting together at least part of the time in person, either for case study visits or in New Haven again. So we will keep you posted on that. And otherwise, spectacular day here in Norwalk. So get out, enjoy it, and have good weekends, everybody. Any final comments from anybody? All right. Well, thanks to our speakers and everybody who, Al.
No, I'm all set. Just saying.
Oh, okay. Just
Have a
saying
great
bye.
weekend.
Okay. Have good
Thank you,
weekends,
everyone.
everybody.
Have a nice weekend.